Okay, so this is going to record chapter 3.1. So chapter 3 is about probability. 3.1 is a lot of the vocab that goes with it. So with probability, we talk about experiments. So the experiment is a planned outcome or operation with controlled conditions. So essentially, it's just what you plan you're going to do, like flipping a coin, rolling a dice, spinning a spinner, and you say, I'm going to do this 10 times. That would be the experiment. The outcome is the result of that experiment. So if you're flipping a coin, the result would be heads or tails. If you're rolling a die, the result would be 1, 2, 3, 4, 5, or 6. Sample space is all of the possible outcomes. So the outcome is what you actually get. The sample space is the possible outcomes. So it's what you actually get. So if I flip a coin, the sample space would be heads or tails. The outcome would be that I actually got heads. The event is any combination of outcomes that you're looking for. We represent that with an E. So we would say like the event is all even numbers on a die. E with squiggle brackets. Probability is the long-term frequency of the outcome. It's always between 0 and 1. Like 5% would be 0.05, or 50% is 0.5 or 1/2. Fair, a fair experiment is when all outcomes are equally likely. So when you flip a coin, it's half and half. Roll a dice, every side is 1/6. Those are considered fair. Now, empirical probability is experimental. That's what you observe when you actually do an experiment. Theoretical probability is the mathematical probability. The difference is, this is what you would expect to happen. So when you flip a coin, 1 out of 2. Experimental is what actually happens. So if I flip a coin 10 times, theoretical, I would expect 5 heads out of 10. Empirical, I might get 8 heads. I might get 4 heads. I might get 3 heads. That's the difference between the two. Or events. So now when we get into, that's vocab. Or events. So what's the probability of getting a 3 or a 4 on a dice? A 5 or a 6 on a spinner? An even or an odd? Things like that. That's what or means. In the world of probability, we use this cup to say or. That symbol means or. So event A is 1, 2, 3, 4, 5. Event B is 4, 5, 6, 7, 8. And then A or B is anything in A or anything in B, so we don't care. So that's 1, 2, 3, 4, 5, 6, 7, or 8. 4 and 5 are in both, but they're still or. So or is anything in either. Doesn't matter. And it has to be in both. That's this upside down one. That means and. So if A is 1, 2, 3, 4, 5, B is 4, 5, 6, 7, 8, and is the ones that are in both, so that's only 4 and 5. So again, or is one event, the other event, or both, and is only both. That's the difference. Okay? Complements are outcomes that are not in the event. So S is 1, 2, 3, 4, 5, 6. A is 1, 2, 3, 4. We write a complement with this little apostrophe. So that means the complement of A. Complement of A, which is the same as anything not in A. So A is 1, 2, 3, 4. Then complement would be 5 and 6, because those are the numbers not in A. So S is saying this is the whole set of numbers, 1 through 6. A is 1, 2, 3, 4. So complement 5 or 6 are the numbers in the set that are not in A. So then we look at some mathematical writing. This here means the probability of A. So if S is all our possible numbers, 1, 2, 3, 4, 5, 6, then the probability of picking something from A is 4 out of 6, because there's 4 options out of the 6 original options, and that reduces to 2/3. The probability of the complement of A, or not A, is 2/6, because there's 2 numbers there out of the original 6. So your probability is just like it was a long time ago, where it's the possible outcomes out of the total outcomes. So in A, we have 4 possible out of the 6 total. In the complement of A, we have 2 outcomes out of the 6 total. Then we simplify. Okay. Now we get to conditional probability. So we're laying conditions or rules on our probability. So you're going to see words like given, A given B. So what's the probability of something given that we're only looking at this area? So it reduces the sample space. It reduces what we're looking at. So that's saying, okay, we'll come back. So if I was talking about the whole College of UMA, maybe I'm only looking at the math majors. That instead of looking at all of the students, I'm only looking at the math majors. So I'm limiting who I'm looking at. Limits what we're choosing from. It's going to be written like this, A given B, with that vertical line. That vertical line means given. So with symbols, you find that probability with probability of A and B over the probability of B. In human words, instead of math symbols, it's the probability of both together over the probability of the given, so what the probability of that limited space. So if we look at one of these, we're going to let A equal 2 and 3. We're going to let B equal 2, 4, and 6. And we want to find what's the probability of picking a number in A, given that we only have the numbers in B to pick from. So on top, we do both. What numbers are in both A and B? So the only number that is in both A and B is 2. So we only have one option in both A and B. On the bottom, we have the given. So the given is B. How many choices are in B? Well, there's 3 choices. That's why it's 1 over 3. So now I'm going to try to get rid of some of this contrast for you, and let's do an example. The sample space is the whole numbers starting at 1 and less than 20. So define S. That means we're going to say S equals, and then we're going to list all the possible outcomes. So we start at 1, and then less than 20, so we would go up to 19. 2, 3, 4, 5, 6, 7, 8, 9, and so on, up to 19. So those are all our possible outcomes. Now, A equals the even numbers from our sample space. So we're going to define A, which means we're going to list all the even numbers that are in there. So 2, 4, 6, 8, 10, 12, 14, 16, 18. B is numbers greater than 13 in our sample space. So I'm going to start at 14 and go up. 14, 15, forgot 16, 16, 17, 18, 19. Okay. So now the probability of A. So we count how many numbers are in A. 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of the total amount of numbers. So that's 19 numbers in the sample space. Probability of B is 1, 2, 3. There's 6 numbers in B out of 19 in the sample space. F says define A and B. So if we were to write that mathematically, that would be A and B. So what numbers are in both A and B? So 14 is in both, 16 is in both, 18 is in both. So those 3 numbers are in both sets. So 14, 16, and 18. G is what is the probability of A or B? Remember, this symbol is or. So that means anything that's in A, B, or both. So we're just going to list all of the numbers in those. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. We already counted 14, so 15's 10. We already counted 16, 17's 11. Already counted 18, 19 is 12. So that would be 12 out of 19. That's one way to do it. You can just draw them out and count them. Mathematically, there's a formula for that. The formula for OR is the probability of A plus the probability of B minus the probability of A and B. So if we do that math, probability of A was 9 over 19. We found that here. Probability of B was 6 over 19. We found that here. And then if we look at F, A and B is 1, 2, 3. So on H, A and B would be 3 out of 19. So if we subtract that, 9 plus 6 is 15, minus 3 is 12. So there's 2 ways to get it. You can just count directly, or you can use this formula for OR. So that's a good formula to know. That's your OR probability formula. All right. Now, I is define not A, or the complement of A. So that's every number from the orange that's not in the teal. So A prime would be 1, 2 is there, 3, 4 is there, 5, and so on. So really, we're going to list all the odd numbers. And then the probability would be how many odd numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of the original 19. So 10 out of 19. Now we're going to do probability of A given B. So A given B means on top, we do A and B. And on the bottom, we do what's given, which is second, probability of B. So A and B was H, 3/19. We found that here. So 3/19. Probability of B was here, so 6/19. So 3/19 divided by 6/19. When you're dividing fractions, you keep the first one, change to multiplication, flip the second one. These are going to cancel, so you get 3/6 or 1/2. If you were to type that in the calculator, you could just type 3 divided by 19 in parentheses, divided by 6 divided by 19 in parentheses, and you get 0.5, which is also 1/2. So that's the same thing. So why don't you take a second and try L, P given A. Pause the video for a second and try that. Okay, on top would be B and A, which is the same as A and B. So that should be 3/19. And on the bottom would be the probability of A, because that's what's listed second. A was 9/19. So you would do 3/19 divided by 9/19, which is 3/19 times 19 over 9, which is 3/9, or 1/3, which is 0.3 repeating. So either of those answers would work. So that is 3.1, the introduction to probability. Let me know if you have any questions.